Okay, as we keep talking about sequences and series, today we're going to specifically focus on the geometric ones. And a geometric sequence is just an exponential function, but only the whole numbers get subbed in. So we can plug in 1 and 2 and 3 and not everything in between. So from our study of exponential functions, you should remember they look like that. But a geometric sequence is just going to be this number and this number and this number, and not all of the real numbers in between those. So some repetitions in what we learned then and what we're doing now. I'm going to start with this. This is cut and pasted from the formula sheet that you will get on the day you take your EOC, your end of course exam. We talked about these two in the last video. I believe I used T's in that video because one of the textbooks uses T's. A sub n is the same as T sub n, so don't worry about that. I'll change over to A's starting now because that's what this formula sheet uses. Today, we're going to worry about these. All right, so this is a geometric sequence. So if you need to know one term in the sequence, you'll use that top one. If you need to know the sum of a bunch of terms, you use that bottom one. All right, so let's just start with some examples. Just plug and chug on most of these. Find the common ratio, the eighth term, and the explicit formula. All right, so common ratio, which is called R, it's the thing that you multiply by to get from term to term. Here's R in the, that'll be on your formula sheet. It's kind of like the geometric version of D. D was what we added each time. R is what we multiply by. So to get from 2 to negative 12, I need to multiply by negative 6. That is pretty obvious in this one. If it's ever not obvious, just take any term and divide it by the term in front of it. So for example, negative 432 over 72 equals negative 6. It's called a common ratio because it's the same all the way through. All right, the eighth term, A sub 8. You're not going to usually be asked for the 112th term because as we learned with exponential functions, these things grow very, very quickly. They hit that tipping point and get really steep, and you're not, your calculator will overflow before you know it. So we're just going to find the eighth term in this case. Now, I'm asked for a term, so that's a sequence. So I'm doing this right here, A sub 8. All right, so that's the first term, 2, times the common ratio, negative 6, to the n minus 1 power. So if I want to get to the eighth term, I need to take 7 steps. And each step is a multiplication by negative 6. All right, so my calculator, 2 times negative 6 to the 7th. My eighth term is negative 559,872. Just oh, we were fine there. If you have an even exponent, you need to make sure you get that negative in parentheses, but we are okay in this case. Negative 559,872. All right, and then the explicit formula. The explicit formula is just kind of, give me a formula that I can substitute into and make it specific to this sequence. So the explicit formula, A sub n, will be 2 times negative 6 to the n minus 1. So it's that exact same geometric sequence formula above, but it has the 2 and the negative 6 in place. You don't have to do any rearranging. We rearranged the arithmetic one the other day, and it was kind of like A sub n equals A sub 0 plus d times n. And it didn't look exactly the same. With geometric it looks pretty much the same. Okay, so let's see what's next. Evaluate the geometric series described. All right, so series means we're finding a sum. So if you think that geometric sequences get big quickly, then geometric series are even that much more big because, or that much bigger because they are not only the big terms, but all the terms in front of those. All right, so this is kind of a simple example just to get familiar with the formula. 4, 8, 16, obviously multiplying by 2 each time. There are different forms of this geometric series equation. So if you see one that looks similar somewhere else, don't feel like it's wrong. All right, so this is going to add up, and it gives that little where r is not equal to 1 qualifier, because if r equals 1, you just have the same term over and over again, and then this formula ceases to exist because the denominator is 0. So this is just a simple plug-in. We've got a1, which is 4, minus a1 times r to the n, so that's times 2 to the 6, all over 1 minus r, so 1 minus 2. They really should put parentheses around that denominator, because when you type it in your calculator, you have to have parentheses down there. You need parentheses around the numerator and the denominator. So let's sub that in, see what we get. We've got, you can do it all in one step. You can kind of do it a little bit at a time. I'm going to go with a one-step method. 4 minus 4 times 2 to the 6. And when you get fractions or negatives in there, you're going to need a lot of more parentheses. My order of operations are going to be fine, because the 2 to the 6 will happen, then the times 4 will happen, and then the 4 minus will happen as is with no extra parentheses. Divided by parentheses 1 minus 2, we can just go ahead and make it -1. But here's the formula, stub in. Honestly, the hardest thing about this formula is getting it in the calculator correctly with all the parentheses. And this is the easiest possibility. Negatives and exponents will make that a little challenging. We'll see that in other examples. All right, so this adds up to 252. Okay, so not too big, because we only added up 6 terms. But my suggestion to you is this. If I ask you, or if the end of course exam asks you this question, for instance, it's great to understand the formula, and the formula will let you do a lot of terms. But if I'm asking you to add up 6 terms, and I've already given you 4 of them, and I'm only multiplying by 2, just go ahead and add up the 6 numbers and make sure it worked. All right, that's sometimes, I would hate for you to miss it using the formula because you didn't just add up the 6 numbers, right? Those 6 numbers should add up to 252. Again, that's only in the simple ones, but you might get a simple one. All right, determine the number of terms. So here's a little variety. We've got the geometric series formula that we're using. So let's make a copy of that. Wrong button. And use it to find a different unknown, in this case the n. All right, so determine the number of terms n. I know that it adds up to -508. I know it starts with -4. N is what I do not know. See, I'm going to put that -4 in parentheses, because there's a minus sign, and also because I need to make sure that negative gets raised to the power. Excuse me, wrong number. I need a1 times r to the n. So let's make that -4 minus -4 times 2 to the n. Forgot my 2. All over 1 minus 2. I'm just going to go ahead and make that the -1. All right, so my unknown is in the exponent spot. All right, we have an app for that. It's called logarithm, opposite of exponent. All right, so I'm going to solve here. I'm going to multiply both sides by -1. I'm going to add 4. I'm going to, let's see, I will next, I'm going to combine, at this point I can combine those 2 negatives to make a positive, so I'll just forget those. I'm going to divide by 4. 512 divided by 4, let's see, that would be something. Should be able to do that. 128. Now I've got 2 to the n equals 128. So you've got a couple of options you can do. You can do logs. You might need to do logs, but this is a power of 2, so I'm not really too worried about it. I know that 2 to the 5th is 32, 2 to the 6th, 64, 2 to the 7th would be 128. I kind of use 2 to the 5th as my starting point because that's the biggest one I remember. So because it was, again, a kind of simple example, I know that n equals 7. But if you had some different numbers in there, you might require a logarithm. All right. So again, nothing too out of the ordinary. Some nice substitute in, plug and chug algebra 1 stuff. Just a little twist that it's not functions we're dealing with. We're dealing with sequences and series. And they'll get a little bit more challenging than this. I don't want you to be bored, so I'll challenge you a little bit. All right, but that is it for this geometric sequence and cities series video. Hoven out.